we have the next lecture on programming by Hrishikesh. Hrishikesh ji.
Yeah. Hi. Can you? Am I audible?
You are audible. Please go ahead, Hrishikesh.
Okay. Thank you, sir. Okay. Hi, everyone. Just put my phone aside. Welcome to the session for introduction to programming. So let's start sharing my screen. Can you all see my screen?
Yes, visible. It's
Okay. One more thing. Hold on. Is this thing coming up? This Zoom control bar on the screen? Wait. I think this will, I'm not able to move it, but I will start then. Hi everyone, welcome to the Programming 101 session here. So I will just go through the chats to see how many people from yesterday are here. I think we have a couple of people from yesterday. So welcome back who were attending yesterday's computational thinking session, and welcome to the new people who are attending this session for the first time. So here in this session, what we are going to do here is I'm going to introduce what basics of, so like yesterday we came to know some of you already have some experience with programming, so that's great. But like in this session we are like more into how to implement it more practically, right? So how it can help you. So, and specifically why we decided to include programming in LSF Science Camp. Why then, like, because it's about science, right? Why introduce programming, right? So, and this whole session will be a very casual thing. If you have any questions, you can just speak up while I'm speaking, and then we can have the discussions there. And I'm not expecting any prior programming experience. You don't need a computer. Like you don't have to follow what I'm. Yeah, Ashik, please go ahead. Yeah, Ashik, go ahead. I think he raised the hand by mistake. Anyway, I'll continue here. So if everything is all right, my audio is all right, I'm communicating correctly, I'll want you to like on chat just put your favorite emojis or something. Then I'll start. Yeah, Heather, nice. Thank you, Heather. Okay. I had this assignment, the first assignment right here. I have written it smash your favorite emojis, but this Zoom bar right here is not letting you see the assignment. But yeah, thank you for your emojis, everyone. So let's start. First of all, the big question, what is a computer? So I thought I would do a poll around how old everyone is. So like when I got introduced to a computer for the first time, I was in class 2. So the idea I had about a computer when I was in class 2 to what I have, the idea that I have about a computer today is totally different. And what I found talking to different people, the idea of a computer is different for different people. It's crazy. It's something that we, yeah, with, well, yeah, go ahead. Philip, you wanted to say something? I think he unmuted himself by mistake. Anyway, so I want to because this is a discussions that we are going to have over the next 1 hour. So I wanted to have a proper definition of a computer here. So whenever we say computer, this is what we think, but it can be thought of differently. What I mean by a computer is anything that does some kind of a computation. So I have a calculator right here. The calculator is a computer. If there is a human who does math in their head, which all of us do, we can be a computer. In fact, the origin of the word computer comes from humans. There was no like machines before. There were like jobs around, people who would actually do mathematical calculations. These people were called computers. Just the way we call humans, other humans engineers. This is a civil engineer, that is a mechanical engineer. There was a thing around computer that used to turn to a human. So later, when that computing thing was done by a machine, we started calling that machine a computer. And then you might have like read about that history of computers things. If you have read those things in classroom, there was this big machines and then they were shrunk, and now our computers is this small. This phone, my watch has a computer in it, right? So that is the idea of a computer. Anything that computes, right? Anything that does some kind of computation. So why I wanted to have this discussion, because with programming, that is the topic of our discussions today. Programming. With programming, you can instruct a computer to do certain things. So when you tell a human, you have a friend, and you are running, and then you're very tired, and you have to tell your friend, hey friend, give me some water bottle. So you are communicating it to them in English, Hindi, or whatever language you want to speak in, right? So then you tell, mere ko pani de do. Then that person will understand. That is another human. That person will understand and give you the water bottle. That is a communication that is happening between you and your friend. You and your friend both are humans. But when we are talking about computer, here we want to communicate with a computer. So the computer directly won't understand English or Hindi, right? You have to tell it in certain ways. That communication that you will have with your computer to instruct it to do something is what programming is. So this is a very abstract sense. So it doesn't have to be writing code. It can be you like touching your screen. That is also an instruction that you are giving the computer. In certain way, you are programming your phone. When you touch it, it does a different reaction, right? So yeah, that's the idea of a computer. So so how many of you have this question in your mind? So like let me know in comments if you are thinking, if you are wondering about like what are the things. So this is a big, so why I'm asking this question, because this is a big image to go through. So if you want, I can explain this. If I learn programming, what can I do, right? We will do actual programming in this session, but before that, I wanted you to understand, if you do this, why you are doing this, that kind of stuff. If you do this, what will be the possibility? I explained you will be able to program a computer, but what does that give you, right? So let me know in comment section if I should go over this little image. I will take 2 yes. If I get 2 yes, I will go through this big map of computer science? Waiting for the comments. Okay, I got one yes. Another yes. Thank you. I'll start with this map. So I won't take too much time. I will just quickly go over the whole thing, right? Because we have limited time today. So first of all, I will go with one. So this is a big map. So I can share I will share the link of this image so that you can like explore it at your own time. But like I will just quickly go over the most basic things here. So here you can see there is something that all of us probably know. So I think all of us know CPU, monitor. So uh, and what a CPU has. So if I am getting too ahead of myself, just let me know. If you feel like if I'm saying if my assumptions like right now I'm assuming it, you know all this, right? If you feel like okay, I don't know, you can let me know in the comments. So yeah, continue. So we have monitor, SSD, CPU, GPU, the things that we use to play games and stuff. And then there is, of course, the power unit. There is keyboard, mouse, right? So those are the like hardware part of the things. These are the basic things. So like I'll zoom out. If I zoom out, you already covered this part. That's nice, right? So we will then cover this part, suppose machine learning. So here uh, there is an image of a cat, and then it does something, and then it has an output called cat. So just from the image, it is able to say it is a cat. That is one domain. Machine learning, you can use programming to do it did something, right? It took the image, did something, and then it outputted that it is a cat. It does it, the machine did something, and that instruction was given by you. You did some programming there. So then like there is computer vision thing, there is this image detection. So when there is satellite imagery, and then you can detect, okay, this is a river, this is land, this is a mountain, those kind of things. You can identify humans, all these things, vision kind of things. And then this machine learning AI, these things are related. Then there are these robots. What are robots? Robots are just computers which have arms, right? You just instruct the robot, like when I press left, move your arm left, that kind of stuff, right? So then there's natural language processing. Some of you probably have heard of ChatGPT and stuff, right? Those things fall under this big domain called natural language processing. Natural language as in like things that humans speak, right? English, Hindi, these are natural language, right? And programming language, which are we are going to learn today. Programming languages are languages that computers understand. We humans also understand. That's the way we are able to communicate to the computer. But natural languages are things that humans used to connect, used to like converse with themselves. So like there is a whole domain where we are trying to teach computers how to understand our human language. That is where this whole um, AI thing, currently generative AI thing, is going on. Then there is Boolean satisfiability. This is related to Boolean algebra, but somewhat different. It's one of the like advanced topics in computer science. So then there's supercomputing, is like very powerful computers, right? Then optimizations. These things are used to do simulations and stuff. So like how do you know that there will be no traffic after this amount of car goes by? So there has to be some city planning, right? If there is a city to be planned, like how many cars that we can allow on a per day, that kind of simulation, that kind of things that we can run simulation and stuff. Then there's graph theory, and this particular the pink part that you see right here is very computer science specific. I have a slide going to 3 slides forward, differentiating between what is programming, what is software engineering, what is computer science, and what is coding. People confuse these 4 terms a lot. So I thought like we will discuss these terms properly. So this pink thing that you see on top, this is more or less computer sciencey. So if you feel like, okay, I don't understand this thing totally, it's okay. It's computer science. Computer science is like, it's a bigger thing than programming. So if even if it's like doesn't not making sense at the moment, it's fine. This so I won't go deep into this, because like explaining this thing would take a lot of time. So like think of this thing as computer science basically. And then yeah, then we have engineering, where you have things like how your browsers work, how these are different languages. These are things that we are going to learn in next couple of slides. And then we have software engineering, which was and is probably my profession. And then we have operating system. These things you can play around with, right? So basically, all of these things, once you learn programming, you unlock all these things. All these things become accessible to you. Similarly, so like I like to think of programming as how humans learn to speak. So when you were born, if your parents did not teach you how to speak or to read, you won't, if they didn't teach you to speak, you won't be able to talk with other humans. If they did not teach you to read, if you did not go to school and learn how to read, you won't be able to just pick up any book and understand what the book is saying. Similarly, like learning programming is sort of just a skill which allows you to explore different things differently. Similarly, I think it goes the same for music. Once you learn music, you understand thing, okay, this is the tone, this is a key, okay, this is E minor, whatever. You just understand what the world is speaking to you, right? The same way, learning programming is going to help you explore this big domain that is of computer science. That becomes accessible to you. It's not easy. It's sometimes easy, it's sometimes hard. There are different difficulty levels, but once you start learning programming, it becomes accessible to you. That is the thing. So to answer this question, if I learn programming, you can do a lot of things. There's no limit here, right? Yeah, I'll go to the next slide now. Yeah, next slide is about programming, coding, software engineering, and computer science. So I want some answers on the chat. The question here is, who knows what a programmer does? Can you you can answer in sentences. You can also unmute yourself and speak up. I just wanted to know what are you thinking in your mind? So I'm asking is, who knows what a programmer does? I'll just write it in my chat as well.
Sir, I think programmers like develop their web development, app development, like that.
Web and app development, right?
Yes, sir.
Yeah, very nice. That's right. But that's not everything, right? Any more answers? What does a programmer do? I think I got one answer. That was wonderful. Thank you for answering. And so here there is these things are quite different. In a way, some of these things are activities, some of these things are disciplines, some of these things are subjects. So programming. I'll so this is what I will do. So yesterday, when we were doing this thing called computational thinking, what we learned there is, when you have a bigger problem, how you solve it is you break it down into smaller parts, and then you try to solve it one part at a time. And then once you solve one part at a time, you end up solving the whole problem. That is the main idea there, right? So now I have a problem right here when we have this slide. The problem right here is, I want to explain this for ideas to you, and I am going to apply computational thinking here. So of all these things, I see a pattern that coding is one of the least interesting things here. So I want to get coding out of here. So that's what I'm going to do. So coding, the word, it has in magazines, media, it has been mixed with programming. It has been mixed with software engineering. And there are people who also use this word called coder, which is fine. But it's just a very analogous, it's a very same to same word with programming. So when you see coding, you don't have to think coding is different than programming. It's the same thing. It's more of a media word. In industry, people usually don't use the word coding because it doesn't really mean anything. So when you say coding, it can be just like I don't know if you have heard about crypto. There's a cryptography thing where you pick one word and then you jumble it to like think you make A to B. So when you are writing A, you are actually writing B. So you just codified A to B. So like the simplest example for here would be so you and I are having a conversation and we want to have establish a code among us, right? So the conversion right here is when you are going to say yes, I am going to understand no. And when I'm going to say no, you are going to understand yes. So this is a secret that is among us. Only we understand. The other world doesn't understand. And when we go to some places and we say yes, then the outer world will think we said yes, but we know that we said no. That is one of a coding. So so the coding word itself is very confusing. So I would usually not use the word coding. So breaking down this problem, we remove coding altogether. We are not going to talk about coding. When we say coding, it's equal to programming. That's what we are going to imagine here, right? Now we have programming, software engineering, and computer science. Okay, so programming is an activity. So if I Google programming, what do I get? I get this image of some person writing things. So like this is the kind of picture I was looking at. So right here, what you are seeing on screen, just open it in a bigger thing. Yeah. Right here, what you are seeing is a programming language. Like people have written some code here. There is some word called void, and then it has some hello and it has again void brackets, and this kind of thing is happening. And like this is just text, right? And when you write something like this, we tend to say in general sense it's programming. This is a program that I wrote, that kind of stuff, right? So this activity of writing this bunch of text that you put into the computer and it does something, that activity is like the idea of programming in general sense. And then software engineering. Software engineering is a profession. Software engineers, what they do is they program, and they not only program. So the answer I got from someone in the when they unmuted themselves and spoke. So they said programmers make apps and websites, right? So that's right, because programmers are all software engineers are programmers, right? But all programmers are not software engineers. So like you can be not a software engineer and still program. It's like you can run, but you do not have to be an Olympic athlete, right? You can run for fun. You can program for fun. So that is one of the main essence I am going to like convey today. You do not have to be a software engineer to program. You do not have to be a computer scientist to program. You can program for fun. In fact, in LSF, we are going to program for fun, we are going to program, like we are going to do embedded programming and this kind of stuff, right? We're just going to tinker around, figure things out, that kind of programming. So like, and by software engineering, you have to do a job, and then you have to build big architected systems, and like software engineering is something like that. So if you build something like Facebook, you will probably need to be a software engineer. You can be a programmer and still make it, but making things at that scale would need you to be very critical about things. And when I say engineering, it is being very precise about things. It's very precise about, okay, the measurement is going to be this. You have to formally verify this is how it is going to be, that kind of stuff. And so that is what I meant software engineering. Software engineering people build these things. And then we have computer science. Computer science is very much theoretical. Like we saw in this image, there is a lot of theory. Turing machine, this is one of the most important topics in computer science, but I'm not going to explain it. Then this information theory, this is, you can see a lot of theory goes in here, right? This lot of theory, this theory are implemented in engineering. This is very similar to scientists and engineering, the idea that we have in general science, right? There are chemical engineers, and then there are scientists in chemistry field. So the scientists invent those things, they discover new things, and the engineers implement it. And this is not always true. Sometimes the engineer is also the scientist, and they are also the programmer. So all of these things can be one single person. So I hope I was able to make the distinction between programming is an activity that software engineers and scientists sometimes do. Scientists more or less deep dive into the theory and discover new things. Software engineers are people who take these ideas from computer science and learn how to do better programming, and then they implement those things into actual products and whatever they want to build. Let me know if this was clear, because this will be very important going forward. Let me know with a yes, no in the comments. Okay, thank you. Next slide. Yeah, so today we are going to learn programming. We are not going to learn coding. We are not going to learn software engineering. We are not going to learn computer science. And of programming, we are going to learn the ultimate basics of this. So we are not like going to do hardcore programming stuff. So just an introduction. So yeah. So before we get started, I wanted to introduce you to this idea of hacking. So how many of you let's phrase this way. What do you understand by hacking? If anybody wants to unmute their speaker and then speak, they can. I'll wait for a bit. What do you think what it means to hack? Okay, I guess no one's speaking. That's fine. I will only say, hi, sir. I'll say what is hack. So culturally, hack usually so this is hacking. There's a hacker who is going to break into something. They are going to do something obstructive to conquer something, information or data. Yeah. This is what I was talking about. So this is the common notion about hacking. So this is what we understand by hack, right? Somebody will steal something. It's almost the electronic equivalent of a thief, electronic equivalent of a dacoit, right? But that's not true. I mean, that's a lot of media and these things spread it that way. But in our technical community, in the hacker culture, if you will, in our programming culture, by hack we mean just fiddling around with something. So we have something and we are very curious about it and we want to figure it out. So suppose I have this mouse and I want to know how this works. I have this pen, I have this like tablet, drawing tablet. I want to understand how this, I will open the screw and then, so a lot of electronics things people do, right? So I have this laptop, I will open it. So that is, we do that thing a lot with physical hardware electronics. So sometimes we like to do it with digital things. We like to do it with websites. We just figure out, and sometimes that leads to security issues where you find other people's information that you were not supposed to find, which Des Young mentioned. So that is one subset of thing that's usually happen. But like by hack, we mean we'll figure out something. Let's figure out. Let's just play around with something. So here, I wanted to demonstrate one thing that we can do with programming. We will hack any website right now in this session, right? So can anyone tell me which website would uh, people like me to hack with? And by hack again, I don't mean I will find security vulnerabilities here. We'll just play around with some website. Suggest me some website in the comments. Any website you want, google.com, Yahoo, anything. Okay, neither says Google. I'll go with Google. Oh, okay. I guess we will have to skip this demo. So, but what I was going to do is I was going to change this web page into something else. But guess we'll try to come back to this in the later part of if we have more time. But this is like this would have been a fun session, but yeah, my keyboard itself is not working when the Zoom session is going on. Anyway, we'll come back to this later. Apologies for this. So so yeah, we'll come to this slide next, and then we have the next slide after it. Uh, uh, slide 8. Yeah. So again, I'm not sure what Mango AI is, but yeah. So again, we'll come back to that slide later, the hacking Google thing. But yeah, let's learn some programming. So I mentioned about talking to computers, right? So if you have to talk to your friend, you will talk in your whatever language you talk with. So, but when you are talking to a computer, you have to use a language that a computer understands, right? So the answer is in the screen, but what language computers understand is ones and zeros. But this idea of, so this what I just said, it will learn everywhere. Everyone will say, okay, computer understands ones and zeros, right? So, but I had a lot of time. I did this online course called NAN to Tetris. I will link it later in the description. It was very good. So it really made me understand what this ones and zeros are. So it all boils down to like electronics. So high and low voltage. So before, like on some threshold, we can say, okay, this is zero. So it's more like signals that you give. So if something is zero and something is one, and with just zeros and ones, you can define a lot of things. So there is something called logic gates. So I just wanted to have another Paul here in the chat about like if you are aware of logic gates. Is anyone aware of logic gates? I think you should be, but let's see. Uh, you can comment if people are familiar with logic gates. Okay. No, that's fine. Okay. So what logic gates are? Uh, so before I explain logic gates, I have to explain logic, right? Logic is anything. So when do you say, okay, this person is becoming illogical, this person is irrational? When you say this kind of things, that means they are not doing things in a very determined way. So when I say, when if I tell someone raise your left hand, and if they raise their right hand, that means they are not acting logically, because you are saying right and they are not doing right, they are doing left. So that then you understand something wrong is happening. So logically means usually, so there is a larger definition of logic, I will not go into that. But here what I mean is, if you say something, it is a very predictive outcome. So so I will explain what you see on screen are logic gates. I will explain you the most simplest logic gate here is, that is the NOT gate. So this NOT gate is something related to what I was explaining few minutes ago. When you and I just know that yes no thing that I mentioned, right? So here this NOT gate is actually, you can if you do electronics class, you can actually make NOT gates in using electronics components. So when there is zero, the output would be one. So this is think of this triangle as a computer. This is one computer. So like I said, a computer is anything that does some kind of a computation. So here, what this NOT gate right here that we are seeing is a computer. So what this computer does is, if you pass zero, it will output one. If you pass one, it will output zero. That is all the computation that it does. But think of how we can mix and match this thing. So this NOT gate, the output of this thing, we can put as the input of this AND gate, and it will do some things that the AND gate does. Then we can put it into NAND gate. Using these different combinations, we can just from the computer understandings ones and zeros, we can make the computer understand a lot of things. So our actual computer that we use has like many logic gates like that, in a very like, it's a very simplified thing, but but in a real world computer we have this zeros and ones flowing through this way. So this is what the computer understands. These are electronics things that are there. If you open your phone, you will see the IC board and stuff. If you open your motherboard, you will see these electronics things. So inside this, you have this like abstract things called logic gates, where you like, and that ones and zeros are voltage passing through those electronics component. So if there is, the voltage is high, we'll consider it one. If the voltage is low, we consider it zero, that kind of thing. So that is the language that computers understand, right? So as humans, I cannot tell, oh, voltage low, computer, voltage low, voltage up. So I cannot speak like that, right? So I need a way to tell the computer, hey, computer, uh, when I raise my hand, understand this and that. So that language is how programming languages were born. So we wanted a communication channel where we can communicate with the computers, right? So, but we cannot talk with this ones and zeros directly, right? So, uh, so here what we see is what I just described. So I think Heather yesterday mentioned that he has programmed in C++. So programming is something that looks like this. So I think all of us here in this video call have done algebra, right? In algebra, you do x equal to something, let y equal to something. It's very similar to that. Here we are doing int something and y into something, and then we are doing something called sum, and then we are here doing x plus y. Then we are doing something called C out, and then sum. So this looks very similar to math, right? And this looks very similar to humans, we understand this kind of thing. And int here, like I'm just getting a little ahead of myself. Int here, that means integer. But yeah, this right here, high level language, this is something that you can understand by looking at it, even if you don't understand exactly, but you can say, okay, there is something called x that equals to y, something is happening. But if you look into the other end here, all you see is 0011 0000101. This I don't understand. But the thing is, the computer only understands this binary thing, and you only understand this high level thing. So there needs to be a translator. So if I go to say Japan, I don't know Japanese, right? And at that point, what I will need is a translator. If I have to talk to a Japanese person, that is exactly what happens here. A programming language. When you say a programming language, it is mostly just translator. You will have your code like this. This is, by the way, code, right? And there is, we can get very, like, we can have a lengthy discussion about what is code, what is program, what is a process, but like that would get complicated. We will not discuss that today. But right here, what you are saying here is high level language code, right? And then, sorry, and then that is getting translated, picked up by something called compiler, and something called object code is happening here, and then there is linker. You do not have to think about compiler, linker, these things right now. Just think of compiler and linker as one thing, and this is basically just translating your high level thing, your code, into this ones and zeros. And because the computer understands this ones and zeros, this is the language that the computer understands, right? Ones and zeros, high voltage, low voltage. So what your programming language does is you write this thing, and then it translates, does something. It is a program on its own, the programming language, right? It does something, and then it outputs this zeros and ones, and the computer suddenly just understands it, and then it is able to give you what you told it to do, right? So I hope so far what I wanted to convey was is clear. Let me know if any questions in the section. Okay, okay, great. So here, okay, I think, can you tell me what this is in the section? Okay, don't tell me what this is. Have you watched this movie? You can tell me in the comment section. This movie came out last year, I think. Some clips, not yet. No. Okay, I think I will carry a copy of this movie with me. This is a nice movie. So this movie is called Oppenheimer, and this movie is about how World War II, and then how how this Project Manhattan came up to be, and it's a very historical thing. But why I am showing this picture, because the idea of computers and programming, at large that we know today, was born at the time where this movie was made, right? So if you like, people who have watched this movie would know this basically, this guy, the protagonist of this movie, is Oppenheimer. That is his name, right? He was the main person who was leading the Project Manhattan thing. And this person next to him, this guy is John von Neumann. He was the main person who designed the computer, which did all the calculation, the military calculation that was needed during the wartime, right? So so this person made this architecture. So this is what the main architecture looks like. We have an input device, and then we have control unit, and then we have memory unit. So I think you have seen these things in other places. We can discuss about this thing properly, but it will take some time to totally understand. So I just wanted to have this like link about how history came to be, and because of this historic events, we have a computer today. Because what we are using in phones and computers all branched off from the World War, right? So yeah. So I think we are running out of time. We have only 10 minutes now. So I will skip this aside. So I will also skip this slide about semantics and syntax. Uh, I think I will include this slide because the next slide would need this. So semantics and syntax. So syntax, semantics is the meaning of what you are saying. Syntax is how you are saying it. So like if you look at this picture, it says me think why waste time say lot word when few word do trick. So you can immediately realize this person is not like writing English properly. They are just writing broken English. But you are able to get what he's telling. Even that person is not saying the whole thing. This is defines the like difference between syntax and semantics. When you talk about syntax, it's specifically about how you write it, like a very minute details. And semantics is at large what it means. So this is very similar to vocabulary and grammar. So you can write some word, and that word can have spelling mistakes and stuff, but it conveys the correct meaning. But if you make like spelling mistake, if you think in a different way, that there is spelling mistake but the meaning is conveyed, right? So that is the difference between syntax and semantics. So when you write a program, you can tell it to write from 0 to 100, but how you, that is the you telling it to write from 0 to 100 is the semantic meaning. So like, and then you will write it in different ways in different programming languages. Just like a human language, you will write something differently in English, and you will write something differently in Hindi, right? So that's the difference between semantics and syntax. So we now come to programming languages. So I want to give you a tour of different programming languages here. So when we talk about programming, the first thing usually when you write is hello world. So right here, I will do one hello world. I think you can see my screen here. Yeah. So this right here is my browser, and this thing that you see, the black box that you see in the middle, is something that we call the terminal. If you code, you will be familiar with it slowly. Don't worry about it. It's being, if you are seeing it for the first time. So I think we from the this things from the previous slide, from this slide, we understand the idea of a high level language, and then it translates it into this binary thing. So now what we are going to look at is some high level language, and one of the high level language is something called Python, right? I'm sure a lot of you have heard of it because it's like very common now. But even if you have not heard of it, that's totally fine. So here I'm going to, before even showing, I'm going to write Python. So this is how you start Python. This may not be the exact way you start Python, but this is how I start Python, right? Python. And then it shows something on the terminal. It says Python something something, Linux something something, help, credits, something. And then it has some greater than arrows, right? And then it's just waiting for us to say something. So think of it this as a interaction between me and the computer. We are going to talk now. So what should we talk about? Let's say something. Why? So how to download Python shell? Dasyam. So I'll tell about why I did not. So tomorrow's session is very much about Python. So like tomorrow's session is like actually doing programming. Today I wanted to have a very like easy session. But downloading Python, this kind of stuff we'll deal with tomorrow. But like we won't even deal with downloading because Python ecosystem is so hard. It will download on your system. It will sometimes not work. Tomorrow we are going to use a different interface where you and I can work together. So like I will explain, but like to download you and those things, we will do it in the offline session when it happens in like. And if you are not there in the offline session, you can message me. We can do this together. But like if we start on the download thing, because everybody's machine is different, right? Somebody will have Windows, somebody will have different machine. So we will do this one-on-one, the download thing. But thanks for reminding. So what Dasyong said, download Python. So I have already downloaded Python. That's why it's running on my computer. So and then I tried to put something here. I will again try putting something 7. Okay, it said something when I put Y, and it did not say anything when I put 7. So it understood 7. And when I put Y, it said something called error. And this is one thing that you will see all over the place when you start programming: error. Okay, this error, that error. So a lot of like even I used to think when I initially started programming, errors are bad. These are not things that you want. But these are things that you actually want because these things help you. This is very similar to when you are learning something. The sooner you fail, the sooner you understand that you are doing something wrong. And then you can course correct faster. Okay, if you are doing the math wrong, rather than doing like 30 pages of math, and then you realize your process was wrong, if you were able to identify your process was wrong in the first page itself, it is good, right? So that's why errors are good. So when I hit Y, it says something error. So it said it's not working. So this is good. We understand that it also has a very helpful thing. Name Y is not defined, right? So these are helpful things. And this is how the computer is interacting with me right now. So again, I will clear everything up. And now I will say, hey, computer, print. If I say print, it is not erroring out, but it is saying something. Now I will say print hello world. Hello. I'll just print hello. I have said print, and then I put a bracket here. And then I put a, I forgot what is this called, but yeah, this quotes, yeah, quotes. And then I put hello, enter. It says hello back. And then I'll do world. It says hello world back. Congratulations, everyone. We wrote our first hello world, and we printed it, and it said hello world back to us. Now, what are we going to look at is, so again, coming back to this idea of syntax and semantics. So what we wanted to do is, we wanted it to print hello world, right? That was the idea. And we did something like print bracket quotes hello world, and then it printed hello world. And we did this in a language called Python. And what this Python thing did behind the scene, as soon as I hit enter, I'll do it again. I have print here, and then I hit enter, and it automatically gave hello world back to me, right? And when I hit enter, what actually happened was back there, it did all this process. It did this thing. It did this. It took that English thing, print hello world. It did some translation, and it converted it to zeros and ones. And then I was able to get hello world back. That is what just happened here, right? So now I wanted to quickly show you this difference in hello world. So let's go for Python, right? PyPHN, yeah. So if you see Python here, this is what we wrote, hello world. I'll just zoom in. This is what we wrote, right? This is the same thing here. This is the same thing. But on this side, you can see there is a list of different things. So these are different programming languages. So there are so many programming languages, and you can write your own programming language if you want. So if I pick some language called say 360 assembly. So this is something called assembly language. It will do the same thing. Whatever you are seeing here, it will do the same thing if you write it and use a assembly language. So this is the syntax. This is how you write it, but it means the same thing, right? And this is some other languages, say COQ. In COQ, you write hello world like this. So it's the same thing. The semantics is the same, but the syntax is different. So some people are writing C++, some people are writing C, some people are writing Python. But ultimately, what you are trying to do ultimately is communicate with the computer. And some languages are better than the other, and that really depends on the context you are writing something in. But for educational purposes and stuff, Python is by and large is a pretty good language to start with. So tomorrow we will be doing more of Python. Just so we understood the main idea behind what are we doing, trying to do when we say we are going to program. We are trying to talk to a computer. We are trying to make the computer do things, right? So, and one of the things I wanted to show was the demo thing. So like not happening today, I guess. But yeah, these are so one of the programs. So yeah, and yeah, oh yeah. So I have another quick demo for you here. So like we printed hello world, right? That is one instruction that happened. We will do another thing here. We'll try to print hello world 100 times. That is the thing that we want to tell the computer. Hey computer, print 100 times. Sorry, print hello world 100 times. It's not detecting my voice for some reason. I guess it has no ways to detect my voice, so I have to type. So I will type again, print hello world. So yeah, let's print hello world 100 times. As you can see, this is Desa kyun, sir, I only know HTML. That's fine. We will learn. We'll learn from scratch. We'll learn from the beginning. Not a worry. But here I'm printing hello world, but this is not very, I have to like manually type it 100 times. That is not very feasible. So this is just a very small snippet for tomorrow's session. So what we are going to do is we are going to use something called a loop, which will tell the computer in advance key, hey computer, this is 100, print hello world 100 times. Then I don't have to keep on manually printing hello world like this 100 times. So the semantics right here is we want to print hello world 100 times, and the syntax for that in Python. So it will be different in a different language, but the syntax for that would be for and one more thing, it's perfectly fine to forget syntax. We forget, like I've been programming for more than 15 years now. So I like forget syntax. So that is okay. Syntax is more like the small details things, but semantics is something that you want to like more focus on. Semantics is the meaning, syntax is the like how you actually write it, that kind of stuff. So I'm not sure if this will work here, but let's try. For in range 0 to 1. So this is just a syntax thing. 1, 2, 3, 4. Print hello world. I'm not sure if this will work. If I hit enter, it might give an error. It might work. Let's see. It worked. It printed 100 times. See? It printed 100 times. So like to verify if it printed 100 times, we can do one more thing. So with this thing, we can print I. That is in the range of 0 to 100, it's going to print it, right? So we also print I with it. Yeah, it printed 99. And this is a task for you. So we did 0 to 100, but the last number here was 99. If you tomorrow can tell me why it is 99 and not 100, that would be nice. That is one of the assignment, if you will. You don't have to think about it. But if you want to think about it, you can. But I will explain you tomorrow why is this 99 and not 100. Okay. Yeah, I think that's all for tomorrow. Tomorrow I will just mention what all the things that we plan to cover tomorrow. I think I have taken 5 more minutes from my start of the session, but I'll quickly conclude. That's like we will have a basic introduction to Python syntax, and don't worry, you don't have to have anything installed. Even if you just have programmed HTML before, that's totally fine. Even if you have never programmed, that is totally fine. We'll start from scratch. We'll learn the basic concept and learn the basic sequencing thing, conditional loops. We just got introduced how to print hello world 100 times. That is what a loop was, input and output. So basically tomorrow we will be getting more into the syntax part of it. So, and syntax is important. Without syntax, the computer will not understand. But really understanding what you are trying to tell the computer is the semantics. So you need both in a way. So tomorrow we will be more focusing on the syntax part of it, which will be beneficial in the offline sessions as well, when we are trying to code electronic components into doing something. So like I said, computers is anything. It doesn't have to be something with a monitor. So that little electronic thing is also a computer. We will write code which will run inside it, and it will do things that we want it to do. So that is why we are learning programming here, right? So these things we will go over tomorrow. And let me know if you have any questions now. I'm happy to answer. Any questions? You can unmute or put it in the chat. Okay, Sakarma says no, no, sir. Fine. Also, one more thing, you don't have to call me sir. I'm just, you can just call me Rishi. That would be great. Yeah, I think I will see you tomorrow.
Okay, sir. Okay, sir.
Yeah.
Thank you, sir.
Okay. Thank you, everyone.
Thank you, sir.
Bye-bye.
Bye bye. Thank
Okay,
you, sir.
thank you, Hrishikesh. Thank you very much.
Good night, sir. Good night.
Good night, sir.
Okay. Good night, Hrishikesh. Thank you.
Very good.
हमें है उजाला अंधियारा मिटाने का, हमें है हौसला नई उमंग बनाने का, हमें है एक जोश हर मंजिल पाने का, हमें है एक जज्बा हर जिंदगी सजाने का, हमें है जोश हर मंजिल को पाने का, हमें है जिंदगी
वो रोशनी जो बनाए आपका भविष्य और उज्जवल। हम हैं ONGC।